In the sixth video from section 6.1, we're going to be taking a look at examples from Hawks, and this is probably just going to be the first video of that because I don't think we can get through all of them, so let's get started. First example. In this problem, I've included what the directions say. All of the problems will say the same thing, so let's read those directions. It says simplify the expression using the properties of exponents. That means all those shortcuts and all of the special notation, the things that you have to memorize. Note, the answer must be reduced to its lowest terms, as always, and all exponents must be positive. So you can have negative exponents all you want when you're working the problem, but at the end you want to change all those negative exponents to positives by moving them. And please be sure to expand the numerical portion of the solution. Remember what that means? So basically that's all that we do in this first problem. So the problem is -3 to the 4th power. Okay, and all we're having to do here is expand that. So we have one exponent, the 4. Who does that exponent apply to? It applies to the whole thing, the -3. So we know that means -3 times -3 times -3 times -3. Well, 3 times 3 times 3 times 3 is going to give you 1. What about our sign? Remember when we did that? We have 1, 2, 3, 4 negatives. 4 is an even number, so we have an even number of negatives, which mean our answer is going to be positive. So the number you would type into Hawks, answer you would type in be 81. Okay, let's do another one. The problem is x to the 8th over x. Oh, I got to tell you, there are so many different ways to do this problem, but let's just do it one way using one of our shortcuts. So we have to identify what exactly is happening here. We have division, and is it division with the same base? Yeah, division of same bases. So the shortcut was to, when you have division of same bases, what do? You subtract the exponents. Okay, so we have base. The easy part is knowing what the base is. So if it's x and x, you're going to have in your answer, this is going to be x. So to get our new exponent, when it's division, we have to subtract. So we subtract 8 minus what? Okay, there's nothing there in front of that x, so if you want to, you can put a 1 to remind yourself that there's an implied 1 there. And x to the 8 minus 1 equal to x to the 7th. I'm getting weird things going on. So let me write that again so it's real clear what we've written. X to the 7th is our answer. Next one. Oh, I like this one. Okay, please notice we've got lots going on. And when I look at this problem, I go, we have regular old numbers, we have some x's, and we have some y's. So do you recognize that in this problem, everything is being multiplied? So what I'm going to do is, I'm going to say, well, that's the same thing as -3 times x to the -2 times y to the 5th times -5 times x squared times y to the -1. In other words, we don't really even need these parentheses because they're telling us to multiply, but everything is being multiplied. So we don't need special consideration for the first part or the second part. Furthermore, I'm going to say, well, you know what I can do? I can rearrange. It doesn't matter the order you multiply. So I'm going to say that's -3 times -5 times x to the -2 times x squared times y to the 5th times y to the -1. Now we're going to take a look at that, and that. So we're going to simplify the like guys by multiplying them. So -3 times the -5, those are just regular old numbers, so you multiply them like you know how. We would get a positive 15. X, so we're multiplying same bases here, right? When we multiply the same bases, our base and our answer of that part is going to be the same thing, x. So what do when we multiply? We add the exponents. That's what the shortcut is. And -2 plus 2 is 0. We'll finish that off in a second. And then we've got our y's multiplying same bases, so the answer is going to be y. The shortcut says add those exponents. 5 plus a negative 1 is 4. There's still a little bit more we can do. What is x to the 0? Well, that's just equal to 1. So 15 times 1, y times y to the 4th, you can just say 15 y to the 4th. Next one. Okay. This one, I think the only thing that's going on here that I notice is that we've got negative exponents. So we've got to change those negative exponents. And I'm going to write this a little bit bigger so I've got plenty of room. Whenever I see a negative exponent, I say, okay, there's nothing else to combine those x's with. So I'm just going to deal with the negative exponent. And I've got another one here. I can't do anything more. I can't combine those y's with any other y's. So I'm just going to deal with the negative exponent. So we've got, remember, all of these guys are considered upstairs, but we've got to move them, and that negative exponent, its instruction is move it. If you're upstairs, go downstairs. So what goes downstairs? Everything, the base and the exponent, everything but the negative. The y to the negative 2, that tells you to move the y squared. What about that 5? Okay, that 5 doesn't have any exponent. It doesn't have any negative exponent, so he just stays up there. There's nothing more to do, so that's our final answer. Okay, we'll come back and do still more examples from 6.1.